Hello everyone, today I'm here to present the paper of estimation of the mass of microplastics ingested by Kala Senathi Raja as the conductor of the underlying research, investigation and writing. Before I start to discuss the paper, I want to show a video clip from a YouTube channel which I will link in the description to visualize the microplastics found in the seafood.
A scientist opened up a can of tuna and put the meat under a microscope. They found that there was microscopic plastic inside of the fish. The plastic that we produce is polluting the ocean, which results in the fish consuming the plastic.
Let's start with a formal definition and groundwork for the microplastics. Microplastics, as you can guess from the name, are plastics smaller than 5 mm. There are two types of microplastics, which are primary and secondary. Primary microplastics are cosmetics, microfibers shed from clothing and other textiles. The secondary plastics are the result of the breakdown of larger plastic items. Microplastics are really persistent contaminants. They are not readily broken down into harmless molecules and take hundreds of years to disintegrate. Now we can start with the paper. The keywords for the paper are exposure pathways, human health, ingestion, microplastics, plastic pollution, and risk. The presence of microplastics in the environment is well known. However, the exposure to humans is not well defined for the human health risk assessments. To provide such frameworks, the determination of an average rate of microplastic ingestion has a critical point. This rate can be used in policymaking and management for public health. The paper concludes from 59 publications, ranging 0 to 1 mm in terms of size. People consume from 0.1 up to 5 grams per week. Microplastics are called cocktails of contaminants due to their association with additives, heavy metals, pharmaceuticals, pesticides, and organic pollutants, since they are absorbed onto microplastics. Those contaminants are associated with obesity, diabetes, cancer, endocrine disturbance, developmental, cardiovascular, and reproductive problems. The studies focus on marine biology and ocean environment, since it's a serious environmental problem as well. This causes a serious gap for human consumption data of microplastics. As you can see from this graph, in recent years, the number of publications for microplastics has increased exponentially. For the data collection, 59 sources are used and categorized in three groups, which are consumables, aquatic environment, and atmospheric environment. Those studies are narrowed down from 93. Not to overestimate, some assumptions are applied as well. I divided those assumptions into two main groups, which are environmental and consumptional. Environmental assumptions include such as surface area of waters, depth versus amount of plastics, beach deposition, etc. As an example, the total length of global coastline is 1.63 multiplied with 10 to 12 meter, and 50% of the total coastlines are littered with microplastics. Consumption assumptions include how much water consumed per capita, how much plastic is present in unit volume. The tap water consumption for each person is taken as 0.45 liter minimum and 1.2 liter maximum daily, which are well below WHO guidelines of 3 to 4 liter per person per day. Here you can see the full assumption list with their references and the related commentary. Next up is the calculation part. Global average rate of microplastics ingested can be found with the multiplication of average number of microplastics ingested and the average mass of individual particles. This formula needs the number of plastics in a medium, the mass of microplastics, which is determined by both uniform distribution method, and particle size distribution using volume density approach. These data are used for three different scenarios. The number of plastics data is derived by many methods relating to their reported style. Particles per meter squared types are multiplied with the surface area of freshwater sources, and particles per kilogram types are multiplied with density of 0.98 gram per centimeter cube, considering PE and PP. Consumables are reported as the number of particles per weight of the consumable except for the water and beer. In this slide, you can see the maximum and minimum numbers for the amounts in the consumables. For the atmospheric environment, the data is omitted from this research due to uncertainties such as breathing rate and lung capacity. The household contains more microplastics than outdoors, and industrial settings will not represent the data accurately. As I mentioned before, for the estimation of average mass of particles, uniform distribution of particles method and particle size distribution method has been adopted. For uniform distribution, lower than 1 mm in terms of size has been used in aquatic environments. For consumables, this method was not feasible, so it was not used. For the particle size distribution method, the aquatic environment assumptions were that the particles are spherical and 0.98 grams per centimeter cube. Midpoint for intervals are multiplied with frequency of particles. For consumables, volume-weighted mean particle size is used. Cubes and spherical models are used for the microplastic shapes. In this slide, you can see the average volume weight and average mass of individual microplastic particles for both spherical and cuboid models. The three scenarios are applied for the modeling. The scenarios were average microplastic particles with uniform distribution, particle size distribution with spherical particles, and particle size distribution with cuboid particles. Since it's a modeling research and uncertainty assessment is also applied, those are the coefficient of variation of 0.5 application, Monte Carlo simulations, and 95% confidence intervals. Coefficient of variation is standard deviation over mean value, which makes the data broader in terms of range when it's applied. In the figure, you can see the representation of 95% confidence interval representation on a normal distribution. Now, we are moving on the results part. One of the aims of this paper was determining the predictor values. Number of particles, size, shape, polymer type, particle size distribution, physical characteristics of individuals, surrounding environment, geological location, demographics, and diet are listed as the predictor values. In this paper, the only first 5 are included in the final product. In this slide, you can see the conclusion of both scenario and uncertainty assessment results. The maximum value for weekly consumption is 5.5 with scenario 1. For the simulation, the max value is 7.9 per week. This paper has a significance for in vitro and vivo models and can be used for human health risk assessments. By using predictor values and the mass ingested, it's a preliminary step for the upcoming research. In terms of toxicology, I want to point out some information on microplastics. We have very limited data on microplastics and their further impacts. They are considered endocrine disruptors, causing reproductive and developmental problems. Microplastics result in disturbance of energy and lipid metabolism, as well as oxidative stress. They can be translocated by persorption or by by endocytosis to the bloodstream, and just by inhalation, lungs are exposed to 26 to 130 microplastics daily, posing a serious problem considering the persistence in the bloodstream. The biggest contributor was drinking water for the uptake in the paper. The finer microplastics are harder to assess, but rather than shape and size, the uptake rate has a more significant role. Paper also discusses the data scarcity and gray areas in the literature. Here you can see the advice for further studies considering the microplastics and their effects. To conclude, it's a great paper with nice background info and a leading paper for future models. Humans are potentially ingesting 0.1 to 5 grams microplastics per week, and there's still a need for more research. This is the paper's reference. Thanks for listening. If you have any question, I would like to hear it on our live session.